So we're going to be taking notes on the first part of lesson 2.7, so chapter 2, lesson 7, and today we're just going to focus in on percent of change. So I've heard from first period familiarity with this one. So today's date is 12/3/15. And of course we had issue, we tried to record in the other period, but it just wasn't having any of it. Oh, I hate that sound. So the percent of change, I'm just going to give you a generic definition of what percent of change is. Oops. I'm going to highlight this. And percent of change is just how much something changes over time. And we have two categories of how things can change. So first we can have a percent of increase. So that would be the item increases over time. And then we also have a percent of decrease. And that would be the item decreases over time. Okay, so those are the only two things that we would be considering. Now, I give this a different name. I call this the grandma problem. And the reason why I call it the grandma problem is that you're interested in doing something and you're like, oh yeah, this only costs so much money. And your grandma says, back in my day, they gave them away for free, right? So grandmas aren't the only ones that do this. Moms and dads do this too. But it's that phrase of back in my day. So I'm going to give you a scenario that was back in my dad's day. Okay? And he was born in the 30s, so he's what is considered a depression baby. He grew up in Missouri, and they didn't have a lot of money. So things, of course, costs are different then than they are now. And here's a prime example. This is a story he's told to me multiple times. His mom he was the only child, so he had to be the man in the house sometimes. And so his mom would give him a dime to go to the store and buy a loaf of bread. With the change from that dime, after buying that loaf of bread, he was able to spend how he wished. His two major choices were pencils or candy. So I'm going to kind of go back, make sure you understand this. So here he is, young lad, given a dime. He goes to the store. He buys a loaf, not a slice, a loaf of bread. With the change from the dime, he could buy candy or he could buy pencils. Now, growing up in the Depression, when things were not plentiful, my dad, as a young boy, opted for the pencils. And I said, why? And he said, because they would last longer. That's the mentality of somebody who's gone through hard times, is that they take what's going to last the longest for them. Because candy is gone in a split second, okay? But pencils are going to last. Now, just to let you know, my dad went on to become a math teacher at a junior college. So education was always important in his mind. Plus, in his rural upbringing, getting out and getting a college education was what would take you to further places, and not to be in that place of not having money and not being able to afford things. So, how much does a loaf of bread cost these days? Yeah. If you're lucky, you can get it on sale for slightly under $2, but they're usually in the $3 to $4 range. So we're going to work out the grandpa back in my day question of how much has bread increased over time. Okay, now obviously bread has increased, right? Because we're not at 10 cents anymore. So back in my dad's day, bread cost, and because he would get change back from the dime, that meant bread had to be less than a dime. So I'm going to just say that the cost of bread was 8 cents. Okay? And then today, I'm going to say that on average, bread's going to cost $3. Okay? Now, when in math we talk about the word change, what mathematics are they asking us to do? Are they asking us to add, subtract, multiply, or divide? They're asking us to subtract. So what we're going to do is to figure out the change in the cost, or the difference. Let me just change color here. Now, your book is kind of interesting because they subtract the same direction every time. However, I don't think we need to do that. I think we can just subtract like normal people. So we have $3 and we want to subtract 8 cents, and that gives us $2.92. Okay, but why would I call this the grandma problem? I haven't heard the back in my day. So what I want to do is compare the change in price to what it was back in my dad's day. So then I'm going to do a comparison to the original back in my day. So then I'm going to take that 292 and I'm going to compare it to the 0.08. All right. Now, I want it to be a percent. So I have to think about, what does the word percent mean? So percent breaks into two pieces. Per. And what operation does per tell me to do? Add, subtract, multiply, or divide. Marlene is mouthing divide. She's right. So we're going to divide by is per. And what does cent mean? Jacob? 100. You've got 100 cents in a dollar. You have 100 years in a century. Okay? So it's 100. So percent means divide by 100. Okay? So what I'm going to do is now take my comparison to the original, and I'm going to create percent, which means compare it to 100. Okay? Most of the problems, we're trying to figure out the percent of change. Sometimes they'll tell us the percent of change, and our job would be to figure out the new number or the old number, whatever. But for a lot of our problems, we're just going to be doing this. Yes, ma'am?
So are we always going to divide by 100, or does it depend?
Percent is always divide by 100. So that right side never changes. And we'll write the formula out in just a minute. We're just kind of still working through this problem. So we do cross products, because we've means extremes, we've talked about that. So this gives me 0.08x, and that's going to equal to 2.92 times 100 is 292. So then we divide both sides by 0.08. And I'm going to use my calculator on this one because it's a really crazy number. So you get 292 divided by 0.08, and the answer you get is astounding. 3,650%. Now, has our price increased or decreased since my dad's day? Increased. So this is a percent increase. And so I just tack on the label increase. So since my dad's day, when he bought that loaf of bread for approximately 8 cents, the price of bread has minimally or approximately increased by 3,650%. Woo! That's kind of crazy. Okay? So let me write down the formula in general, what you're going to be doing. And then, so the formula for percent increase, decrease, or just percent of change. And then I'll give you 2 examples, like how the book's going to set it up for you. So you're going to have the difference between your 2 values. You're always, back in my day, comparing to the original or the old value. Because I want to turn it into a percent, or I'm going to use a percent symbol. We're going to set it equal to some number over 100. Now, this normally what I put here is your x, okay? Because that's normally what we're trying to figure out. So that's a scenario that uses this idea, and that's the formula I'm going to use every single time. So what I want you to remember is that when you're, okay, I've got the difference, what am I comparing it to? Back in my day. So you're always thinking back, what was it in the past, okay? So the way that the problem gets set up for you is they just give you 2 pieces of information. And it's based on those 2 pieces of information that you can calculate out the answer. So, example, oops, sorry, go back to black. Find percent of increase or decrease. So again, what the book is going to do is tell you how to subtract, and they always subtract the same way. Sometimes the answer is positive, sometimes the answer is negative. A positive answer would mean you had an increase. A negative answer means you would have had a decrease. We're not going to do it that way. We're going to take big number, take away small number, because that's how we do the subtraction. And we're always going to look at those 2 original numbers and determine before we begin, is this an increase or a decrease? Okay? So, you're going to be given 2 pieces of information. The book uses these words. Original, and in our case is 20, and then final, and in our case is 23. So we're going from old to new. Your question that you have to answer before you even do any setup is this an increase or is this a decrease? Increase. So anytime you go from old to new and the new is more, then this is called an increase. So you're going to add the words increase to the end of your answer. Okay? All right, and now we're just going to set it up. So the difference is I take my 2 numbers and I subtract them. That's a difference. Old. I'm comparing back to my day, what it was before. That's your 20. And then equals x over 100. And then you simplify and then do means extremes. So this gives me 3 over 20 equals x over 100. Now when I do the means extremes, I like to do the one that includes the x first. So that gives me 20x equals 3 times 100 or 300. And then I divide both sides by 20. So a 0 cancels out and 2 goes into 30 15 times. So my answer isn't x equals 15. My answer is a 15%, because the x is a percent number, increase. That's the minimum requirement for how you answer this. Number, percent, either increase or decrease. Okay? So let's do one that goes the other direction. Let's say your original was 25, oops, equals 25, and your final was 17. Okay? So looking at your 2 numbers, is this an increase or a decrease? Yeah, if you notice, you went from a large number to a small number, so that's a percent decrease. So the setup is the same. I'm going to take my 2 numbers and subtract them. So I have 25 take away 17, and I'm going to compare it back to the old number, back in my day, to 25. On the right side it's always x equals 100, or x over 100, excuse me. That's never going to change on that side, okay? Well, that's not true. It's always going to be divided by 100, and sometimes they'll give you that number that is the x value. So then I simplify, and I get 8 over 25 equals x over 100. So I do my cross products, and I get 25x equals 8 times 100, which is 800. Then I divide both sides by 25. And since 25 goes into, let's see, 100 4 times, and I've got 800, that would give me 32. So I get x equals 32. But how I write my answer is a 32% decrease. Now, these types of problems are actually really applicable in the business world because you could be looking at how well a product sold from this last year to this year. If it's increasing, then that's going to tell you we're going to keep this product, or it may say we need to increase how much we have available because it looks like there's going to be this trend of people wanting it more. It could be going the other direction where you sold fewer this year than you did the past year. Well, then maybe that tells you this is a product we're not going to offer anymore because there's not as much interest in it. Or minimally, I'm going to decrease how much we're going to purchase because what they don't want is inventory sitting on their shelf that they can't use. So this is an idea that gets used in businesses. Now, a lot of parents will say, oh, I've never used it and I'm in business. It's because they have a program that does that for them and they don't even think about it. But that percent of increase, decrease is very important in the business world. Okay, so that's it for our notes.